Now here we will start the new topics, that is a logarithmic differentiation. The complicated functions given by formula involves, if we take the following, and that involves the product, quotient and the powers of, and there is contains the powers can be simplified more quickly by logarithm on the pass. This allows us to use the laws of logarithms to simplify functions and simplify easily, especially when the functions are of y is equals to f of x raised to g of x, that is logarithms on both sides, which simplifies to of y. If we take the log on both sides, then log of y is equals to g of x. Now it is again to find if there is a complicated function, function raised to function, and multiplication of the different powers. This process of is called logarithmic differentiation. Now there are examples. Differentiate the following with respect to x. Y is equals to plus cubic root of x cube plus 5 bracket square x square plus 1 bracket as complicated function. If you want to differentiate it, and if you take the log on both sides, then simplified manner, x square plus 3 bracket raised to 2 root of x cube plus 5 bracket root of 2x square plus 1 bracket cube. Take log on both sides, equals to log of x square plus 3 bracket square and the cube x cube plus 5 bracket square minus log of 2x square plus 1 cube and raised to 1, that is the log of 2x square 3 by 2. Now again in simplified manner, here is a product of the two terms, therefore log of x square plus bracket square plus log of x cube plus 5 raised to 2 minus log of 2x square plus 1 raised to 3 by 2. That of x square plus 3 plus 2 upon x plus 5 minus 3 plus 1. Now differentiate this with respect to x. Now the derivative y by dx, the derivative log of y is 1 upon y. It is a composite. Log of x square plus 3, that is 1 plus 3 into ddx of x square plus 3. 3 log of x cube plus 5, that is 1 upon x cube plus into ddx of 3 upon 2 into 1 upon 2x square plus 1 into ddx of 2x. That is a 2 upon x square plus 3 and derivative of x square is a 2x plus 2 upon 3, 1 upon a plus the derivative and 5 0, 3 by 1 upon 2x square is a 4x, derivative of 1 is 0, and this is the 4x upon x square plus 3 plus 2x square upon x cube plus 4. Here is 3 and 3 get cancelled, minus 6x upon 2x square, and that's why dy by dx is equals to y into upon x square plus 3 plus 2y plus 5 minus 6x upon 2x. E raised to x square raised to x upon 2 1 plus x square bracket raised to 3 by 2 into cos cube x. Now again take log on both sides. Log of e raised to x square tan of x upon 1 into cos of x, that is the log of e raised to x square plus log of tan of x raised to 2 into minus log by 2 plus log of cos of x bracket raised to 3. I forget to write the raise. Now this is the log of e raised to x of e to the base is 1 plus x upon 2 log of tan of x log of 1 plus x square minus 3 cos x back to x upon y into dy by dx 2x upon 2 is 1 tan of x into derivative of tan of x is a sec square x plus 1 upon that is a derivative of x is 1 of x minus 3 by 2 into 1 upon 1 plus x square into derivative of 1 plus x square is a 2x, and next is a minus 3 into 1 upon cos x and derivative of cos x is a minus sin x. Therefore dy by dx is y into in bracket x plus x upon x plus 1 upon 2 log of tan x minus 3x upon 1 plus x square plus 3 tan x therefore dy by if we simplify that is this is sin upon cos and cos square 1 that is a 2 upon 2 sin x 1 upon 2 log of tan of x plus x square plus 3 tan x. Therefore dy by dx is equals to y in bracket 2x plus 2 sin into cos x cos sin of 2x and x plus 1 upon 2 log of tan of x minus 3x upon 1 plus x square plus 3 third one 1 plus x into 2x plus 3 raised to 5 plus 4 raised to 2 upon 3. Now first of all take log on both sides. If you take log on both sides then you will get log of 3 upon 2 plus by 2 log 2x plus 3 plus 2 upon 3 log of 3x plus 4 2x. Derivative of log of y is 1 upon y into dy by dx 3 by 2. Derivative of log of 1 plus x is to derivative of x plus 1 x is 1. Next is 5 by 2. Derivative of log of 2x plus 3 is 1 upon 2x plus 3 into ddx of 2x plus 3. And derivative of 2x plus 3 is Derivative of 2x is 2, derivative of 3 is 0. Next is 2 upon 3 into 1 upon 3x plus 4 into derivative of 3x plus 4, which is 3. Y by dx is equals to y into 3 upon 2 in bracket x plus 1 plus 2 upon 3x plus 4. And this is the dy by dx. We substitute the value of the y. That is the dy by dx. The previous purpose I forget to write that 2 or cancellations of the 2 is x raised to a plus x raised to x. X derivative of x raised to a is a into x raised to a. ddx of x raised to x into log of a. Now we want to find out x raised to x. We'll substitute u is equals to x raised to x. Take both sides. U is equals to x respect to x. 1 upon u into the product will x into derivative of log of x is 1 upon x plus derivative of du by dx is equal to du by dx 1 upon u into du by x, x it cancel 1 plus log 2 in bracket 1 plus log x. Now u is x raised to x in bracket 1 plus log x. Now substitute that is a dy by dx is equals to a into x raised to n x raised to x in bracket 1 plus log x and plus fifth one y is equals to tan x minus x raised to y is equals to sin x raised to tan x minus x raised to log of x. This type of the examples asked in exam. Now we'll substitute this is u and v and then take log separately independently and find their differentiation. Therefore see this here. Y is equals to u plus v. U is equals to sin x raised to tan x. Take log on both sides. Log of u is equals to tan of x also dy by dx is equals to du by dx minus dv by dx. Log of u is equals to tan of x into log of sin x. Now differentiate this with respect to x, that is 1 upon u into du by dx. Now we will apply here the product rule. Tan of x into log of sin x, that is 1 upon sin x into derivative of sin x is cos x plus log of sin x into derivative of tan x is the sec square x. Now evaluate this, that is you will get du by dx is equals to u into tan x into cos upon sin, that is a cot x plus sec square x into log of sin x bracket complete. Therefore du by dx is equals to u into tan into cot is 1 plus sec square x into log of sin x. Therefore v is equals to, next is x raised to log x. Take log on both sides. Log of v is equals to log of x into log of x. If we take log both sides, then this exponential power will be here. That is log of x into log of x. That is log of x bracket square. Now differentiate this with respect to x log of. log of x bracket square. Now what is the derivative of log of x? That is the 2 times log of x into derivative of log of x is 1 upon x. By mistake it was the x there. Therefore dv by dx is equals to v into log of x upon x. Therefore dv by dx is equals to x raised to log x in bracket 2 log of x upon x. Is there a mistake by me again? That is a 2 into x raised to log x upon log of x upon x. This is the dv by dx. Now what is the y's? That is the dv by dx is equals to du by dx minus dv by dx. Therefore dy by dx is equals to u in bracket 1 plus sec square x into log of sin x minus 2 into x raised to log x into log of x this must be your x. The same mistake is repeated here. Therefore dy by dx is equals to sin of x raised to tan x in bracket 1 plus sec square into log of sin x minus 2 into x raised to log x into log of x upon x. Now the implicit functions. What is meant by the implicit function? That is, one variable can be expressed in terms of the other variables. That is, now see this here. Here is x raised to 5 plus x into y cube plus x square into y plus y raised to 4 plus y raised to 4 is equals to 4. That is, here we cannot find x or y in terms of x and y independently because the function is complicated. And to find out the derivative of this type of the function, we take first log on both sides and then differentiate. If an equation in x and y is given, but x is not an explicit function of y, and y is not explicit function of x, then either of the variables is an implicit of the other. That is, one variable cannot be expressed in terms of the other variable. Now the derivative of implicit functions. In these topics, I think that there is no rule. Find dy by dx if x raised to 5 plus x into y raised to 3 plus x square y plus y raised to 4 is equals to 0. Now differentiate this with respect to x. Now here we are differentiating. See this here. The derivative of x raised to 4 is a 5x raised to 4. Now in this case x into y cube. For this we take the ddx of x into y cube. Again here is a product of x into y. Therefore it is a ddx of x square y plus derivative of y raised to 4. And the derivative of y raised to 4 is a 4 y raised to 3 into dy by dx is equals to 0. Now here and in these two cases we will apply here the product rule. That is a 5x raised to 4. Derivative of x is 1y cube plus x into derivative of y cube, that is a 3y square into dy by dx. Next is plus ddx of x square, derivative of x square is a 2x into y plus x square into dy by dx plus 4y cube into dy by dx is equals to 0. Now 5x raised to 4 plus y cube plus 3xy square into dy by dx plus 2xy plus x square into dy by dx plus 4y cube into dy by dx. Now take the terms of this dy by dx as a common. Therefore 5x raised to 4 plus y cube plus 2xy. These are the terms which are other than dy by dx, and these are the terms we have the dy by dx as a common. That is a 3xy square plus x square plus 4y cube into dy by dx is equals to 0. Therefore separate it. Therefore dy by dx is equals to minus 5x raised to 4 plus y cube plus 2xy upon 3xy square plus x square plus 4y cube. Therefore dy by dx is equals to 5x raised to 4 plus 2xy plus y cube upon x cube Now next example is y cube plus cos of xy is equals to x square minus sin of x plus y. Again normal differentiate this with respect to x. The derivative of y cube is a 3y square into dy by dx, and the derivative of cos of xy is a minus sin of xy into ddx of xy equals to derivative of x square is a 2x, and the derivative of sin of x plus y is a cos of x plus y into ddx of x plus y. That is a 3y square into dy by dx. Now here is a sin of xy and the derivative of xy. The derivative of x is 1 into y plus x into derivative of y is a dy by dx. Here is a 2x minus cos of xy and ddx of x plus y. The derivative of x plus y is a derivative of x is 1 and derivative of y is a dy by dx. Now again simplify this, that is a 3y square into dy by dx minus y sin of x plus y minus x sin of x plus y into dy by dx, that is equals to 2x minus cos of x plus y minus cos of x plus y into dy by dx. Now collect the terms of the dy by dx. Now here is a 3y square minus x sin of x plus y and plus cos of x plus y into dy by dx, that is equals to y sin xy plus 2x minus cos of x plus y, and that's why dy by dx is equals to there is a y into sin of x y plus 2x minus cos of x plus y upon 3y square minus x into sin of x plus y plus cos of x plus y. Therefore, dy by dx is equals to 2x plus y into sin of xy minus cos of x plus y upon 2y square minus x into sin xy plus cos of x plus y. This is the dy by dx. Now the third one, x square plus e raised to xy is equals to y square plus log of x plus y. Now differentiate this with respect to x. Derivative of x square is a 2x and the derivative of e raised to xy is a e raised to xy into ddx of xy. Derivative of y square is a 2y into dy by dx, and derivative of log of x plus y is a 1 upon x plus y into ddx of x plus y. This is a 2x e raised to x into y. Now here is a product rule, that is a ddx of x into y. Derivative of x is 1, keep y as it is, plus x as it is, and derivative of y is a dy by dx. 2y into dy by dx plus 1 upon x plus y into derivative of x plus y. Derivative of x is 1 and derivative of y is a dy by dx. Again, normal simplification is here. Collect the terms of the dy by dx on one side and other terms which are not containing the dy by dx another side. Therefore, 2x plus y into e raised to xy plus x into e raised to xy into dy by dx is equals to 2y into dy by dx plus 1 upon, if we multiply this, 1 upon x plus y into 1. Therefore, 1 upon 1 plus x y plus 1 upon x plus y into dy by dx. Now collect the terms of the dy by dx. X into e raised to xy minus 2y minus 1 upon x plus y into dy by dx, and that whole is equals to minus 2x minus y into e raised to xy plus 1 upon x plus y. Therefore, now here we will simplify here. In a simplified form, that is x plus y will be the LCM here. Therefore, x into x plus y e raised to x plus x into y minus 2y into x plus y minus 1 upon x plus y into dy by dx is equals to. Now here is also, if we simplify, then you will get minus 2x into x plus y minus y into e raised to x y into x plus y plus 1 upon x plus y. Now on the both sides x plus y will get cancelled. Therefore, see this here. This get cancelled. Therefore, dy by dx is equals to minus x in bracket x plus y minus y e raised to x plus y plus 1 upon x into in bracket x plus y e raised to xy minus 2y in bracket x plus y minus 1, and simplify this. If we take the minus sign common from the numerator, then you will get 2x in bracket x plus y plus y into e raised to x plus y into x plus y minus 1 upon, again if we take the minus sign from the denominator, minus, here is a minus in bracket 2y in bracket x plus y minus x into x plus y a raised to xy, and this is the minus 1. This minus minus will become plus, therefore dy by dx is equals to 2x. This is the dy by dx. Next example. This is again very important examples which are asked frequently in number of the times in the board exam. X raised to m into y raised to n is equals to x plus y raised to m plus n. Then prove that dy by dx is equals to y upon x. First, take log on both sides. That m into log of x plus n into log of y is equals to m plus n log of x plus y. Now differentiate this with respect to x. That log of x is 1 upon x, m upon x plus n into n upon y into derivative of y is dy by dx is equals to m plus n log of x plus y is 1 upon x plus y into ddx of x plus y. Derivative of x is 1, y is a dy by dx. Again, normal multiplication, collect the terms of the dy by dx on the left hand side and other than dy by dx to the right hand side. M upon x plus n upon y into dy by dx, m plus n upon x plus y into 1, m plus n upon x plus y into dy by dx. Therefore, n upon y into dy by dx minus m plus n upon x plus y into dy by dx is equals to m plus n upon x plus y minus m upon n. Now simplify this, take the dy by dx common, n upon y minus m plus n upon x plus y into dy by dx. And this is m plus n into x, cross multiplication m plus n into x plus y upon x into x plus y. That is n into x plus y minus y into m plus n upon y into x plus y into dy by dx. That is equals to mx plus nx minus mx minus my upon x into x plus y. Now x plus y on both sides get cancelled. And therefore dy by dx is equals to, now some terms are still present here. This is the y upon x, therefore it is y upon x, nx minus my, and if we simplify this, it is a nx ny minus my minus ny. Therefore you will get nx minus my, and to the numerator nx minus my, to the denominator nx minus my get cancelled, and that's why dy by dx is equals to y upon x. Now the next example is sine of p x raised to m minus q y raised to m upon p x raised to m plus q y raised to m is equals to r. Then show that dy by dx is equals to y upon x. All solved examples are very important, where r is a constant. Now here is a sign of p x raised to m minus q y raised to m upon p x raised to m plus q y raised to m is equals to r. Therefore, p x raised to m minus q y raised to m upon p x raised to m plus q y raised to m is equals to sine inverse of r. And this is another constant that is equals to t. Px raised to m qy raised to m is equals to t in bracket px raised to m plus qy raised to m. Px raised to m minus qy raised to m is equals to t px raised to m plus t qy raised to m. Therefore, px raised to m minus t px raised to m is equals to t qy raised to m plus qy raised to m. Take x raised to m as a common. P into x raised to m as common. Then in bracket you will get 1 minus t. From the other side, take q and y raised to m as a common. Therefore, y raised to m is equals to p into in bracket 1 minus t upon q into bracket 1 plus t x raised to m. Now differentiate this with respect to x. That is y raised to m is equals to s into x raised to m. There is another constant s is equals to, that is s is equals to p into in bracket 1 minus t upon q into in bracket 1 plus t. Now differentiate this with respect to x, and derivative of y raised to m is equals to s into x raised to m into y raised to m minus 1 into dy by dx is equals to s into m into x raised to m minus 1. Therefore, dy by dx is equals to s into x raised to m minus 1 upon y raised to m minus 1. Therefore, dy by dx is equals to y raised to m upon x raised to m into x raised to m minus 1 upon y raised to m minus 1. This is the value of s. Therefore, you will get dy by dx is equals to y upon x. Next example, sec inverse of x cube plus y cube upon x cube minus y cube is equals to 2a. Then show that dy by dx is equals to x square into tan square a upon y square, where a is a constant. Now we have given that sec inverse in bracket x cube plus y cube upon x cube minus y cube is equals to 2a. Therefore, x cube plus y cube upon x cube minus y cube is equals to sec of 2a. If you take their reciprocals, then you will get x cube minus y cube upon x cube plus y cube is equals to cos of 2a. X cube minus y cube upon, that is x cube minus y cube is equals to, if we multiply it, x cube plus y cube, that is x cube cos of 2a plus y cube cos of 2a. X cube minus x cube into cos of 2a is equals to y cube plus y cube into cos of 2a. Collect the term of the x cube, 1 minus cos of 2a, y cube 1 plus cos of 2a. Therefore, y cube is equals to 1 minus cos of 2a upon 1 plus cos of 2a into x cube. Therefore, you will get y cube is equals to 2 sin square 2a upon 2, that is a 2 sin square a, and 2 cos square 2a upon 2 into x cube. These two terms will get cancelled. You will get y cube is equals to tan square a into x cube. Now differentiate this with respect to x. That is a 3y square into dy by dx is equals to tan square a into x cube means what? 3x square. That is a dy by dx is equals to x square into tan square a upon y square. That is 3 get cancelled on both sides. Dy by dx is equals to x square tan square a upon y square. Now the next is very famous example. This is all solved examples are very important. That is in root of tan x plus in root of tan x plus in root of tan x up to the infinity. Then show that dy by dx is equals to sec square x upon 2y minus 1. Now we have given that y is equals to in root of tan x plus in root of tan x plus in root of tan x up to the infinity. This is equation number 1. Squaring on both sides. Therefore you will get y square. If we square this, then what will happen? This is the tan x and this term will remain as it is. And again this is nothing but the y. Therefore, that is y square is equals to tan x plus y. From 1. Now differentiate this with respect to x. Derivative of y square is a 2y into dy by dx. And derivative of tan x is a sec square x and derivative of y is a dy by dx. Collect the terms of the dy by dx. Therefore, you will get two y into dy by dx minus dy by dx is equals to sec square x. Therefore, dy by dx, that is a 2y minus 1 into dy by dx is equals to sec square x. Therefore, dy by dx is equals to 2y minus 1 sec square x upon 2y minus 1. Next is this is the 6th one. If in root of 1 minus x square plus in root of 1 minus y square is equals to a in bracket x minus y, then show that dy by dx is equals to in root of 1 minus y square upon 1 minus x square. Now here is also very important example. We have the substitution x is equals to sin alpha and y is equals to sin beta. Therefore, x is equals to sin alpha and y is equals to sin beta. If we substitute, then you will get also alpha is equals to sin inverse of x and beta is equals to sin inverse of y. Now the equation 1 becomes in root of 1 minus sin square alpha plus in root of 1 minus sin square beta, that is equals to a in bracket sin alpha minus sin beta. That is 1 minus sin square alpha means what? Cos alpha. 1 minus sin square beta means what? Cos beta. that is equals to a in bracket sin alpha minus sin beta. That is the 2 cos of alpha plus beta upon 2 into cos of alpha minus beta upon 2 is equals to 2a cos of alpha plus beta upon 2 sin of alpha minus beta upon 2. These 2 get cancelled on both sides. That is the cos of alpha minus beta upon 2 is equals to a sin of alpha minus beta upon 2. Cos of alpha plus beta upon 2 on both sides get cancelled, and that's you will get. That is the cot of alpha minus beta upon 2 is equals to a. Normal simplification is here. Therefore, alpha minus beta upon 2 is equals to cot inverse of a. Therefore, alpha minus beta is equals to 2 cot inverse of a. But what is alpha? Alpha is a sine inverse of x. It's a sine inverse of y is equals to 2 cot inverse of a. Now, differentiate this. Then you will get derivative of sine inverse of x is 1 upon in root of 1 minus x square. Derivative of sine inverse of y is 1 upon in root of 1 minus y square into dy by dx is equals to 2 cot inverse. That is 0. It's a derivative 0. Therefore, dy by dx is equals to, that is in root of 1 minus y square upon 1 minus x square, and hence dy by dx is equals to 1 minus y square upon 1 minus x square. Now we will start the exercise 1.3. Differentiate the following with respect to x. That is x plus 1 bracket square upon x plus 2 bracket cube upon x plus 3 bracket raised to 4. Now here y is equals to x plus 1 bracket square upon x plus 2 bracket cube upon x plus 3 bracket raised to 4. Take log on both sides. Therefore, log plus 1 minus log of x plus 2 minus 4 log of x plus 3. Now differentiate this with respect to x. That is 1 upon y into dy by dx is equals to 2 upon x plus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. Therefore, dy by dx is equals to y into 2 upon x plus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. Therefore, dy by dx is equals to x plus 2 1 bracket square upon x plus 2 bracket cube into x plus 3 bracket raised to 4 2 upon x plus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. And here the answer. Now see this again. This is y. Take log on both sides. Therefore, you will get dy by dx is equals to, simplify the terms. Now the next example. Second, that is in cubic root of 4x minus 1 upon 2x plus 3 into 5 minus 2x bracket square. Y is equals to cubic root of 4x minus 1 in bracket 2x plus 3 into 5 minus 2x bracket square Take log on both sides. Therefore, you will get log of y is equals to 1 upon 3 log of 4x minus 1 minus log of 2x plus 3 minus 2 times log of 5 minus 2x bracket complete. Now differentiate this with respect to x. That is 1 upon y into dy by dx is equals to 1 upon 3 bracket complete 1 upon 4x minus 1 into derivative of 4x minus 1 is 4. 1 upon 2x plus 3 into ddx of 2x plus 3, 2. That is a minus 2 upon 5 minus 2x into ddx of 5 minus 2x is a minus 2. Therefore, 1 by 3, 4 upon 4x minus 1 minus 2 upon 2x plus 3, 4 upon 5 minus 2x. Therefore, dy by dx is equals to y upon 3 in bracket 4x minus 1 minus 2 upon 2x plus 3 plus 4 upon 5 minus 2x. Substitute the value of y. That is the cubic root of 4x minus 1 upon 2x plus 3 into 5 minus 2x bracket square in bracket 4 upon 4x minus 1 minus 2 upon 2x plus 3 plus 4 upon 5 minus 2x and bracket complete. This is the dy by dx. Now see this again. This is the y is equals to take log differentiate this 1 upon y into dy by dx. Now the next third example, x square plus 3 bracket raised to 3 by 2 into sine cube of 2x into 2 raised to x square y is equals to here we will write that is y is equals to x square plus 3 raised to 3 by 2 sine cube of 2x into 2 raised to x square. Take log on both sides 3 by 2 log of x square plus 3 3 log of sine of 2x plus x square log of 2. Now differentiate this with respect to x, that is derivative of log of y is 1 upon y into dy by dx 3 by 2 into 1 upon x square plus 3 into ddx of x square plus 3 which is 2x. 3 upon sine of 2x into ddx of sine of 2x is a cos of 2x into derivative of 2x is 2. This is very important. That is a 1 upon that is a sine of 2x. Derivative of sine of 2x is a cos of 2x into derivative of again composite it is a derivative of 2x is 2. Now next is the derivative of x square is a 2x into log of 4 and normal simplification is here. That is 1 upon y into dy by dx is equals to 3 upon 3x upon x square plus 3 plus 6 upon cos of 2x upon sine of 2x that is a 6 cot x cot of 2x plus 2x into log of 4. Two x into log of 2, sorry. Therefore, dy by dx is equals to y into 3x upon x square plus 3 plus 6 into cot of 2x plus 2x log of 2. Substitute the value of the y, and that's why you will get the answer. That is a x square plus 3 raised to 3 by 2 sine cube of 2x into 2 raised to x square in bracket 3x upon x square plus 3 plus 6 cot of 2x plus 2x log of 2. This is the dy by dx. Now next is fourth one, x square plus 2x plus 2 raised to 3 by 2 upon root x plus 3 bracket raised to 3 cos x bracket raised to x. Let y is equals to x square plus 2x plus 3 2x plus 2 raised to 3 by 2 upon root x plus 3 bracket cube cos x bracket raised to x take log on both sides, that is log of y is equals to 3 by 2 log of x square plus 2x plus 2 minus 3 log of root x plus 3 minus, that is x log of cos x directly. Here is a power, becomes x log of cos x. Now differentiate this with respect to x, that is the log of y means what? 1 upon y into dy by dx. This is the 3 by 2 1 upon x square plus 2x plus 2 into derivative of x square plus 2x plus 2. X square is a 2x and derivative of this 2x is 2 minus 3 upon root x plus 3 into ddx of root x plus 3. Derivative of root x is 1 upon 2 root x. Next is, I will show you, it's very hurry. Now see this again. This is the problem. That is log of y is equals to 3 upon 2 log of x square plus 3 log of sine of 2x plus, this is x square into log of 2, differentiate this with respect to x, 1 upon y into dy by dx is equals to 3 by 2, 1 upon x square plus 3 into derivative of x square plus 3 is a 2x plus 3 upon sine of 2x into derivative of sine of 2x is a cos of 2x into derivative of 2x is 2. Derivative of x square is a 2x log of 2. Therefore, 1 upon y into dy by dx is equals to 3x upon x square plus 3 plus 6 cot of 2x plus 2x log of 2. Therefore, dy by dx is equals to y in bracket 3x upon x square plus 3 plus 6 cot of 2x plus 2x log of 2. And hence answer. Now the next is this was the problem. Take log on both sides. After differentiation 1 upon y, this is the 3 by 2 1 upon x square plus 2x plus 2 and derivative of 2x square plus 2x plus 2 is a 2x plus 2. Again the differentiation of this, that's a minus 3 upon root x plus 3 into ddx of root x plus 3. What is the derivative of root x? Root x is 1 upon 2 root x and this is the 1 upon 2 root x. Derivative of 3 is 0. Next is here we will apply the product rule. What is the product rule? That is first of all derivative of x is 1. Therefore it is the 1 into cos of x. And what about the next? Keep this x as it is. Derivative of log of x is the 1 upon cos x into derivative of cos x is a minus sign. And this minus and minus will become plus. There is a sin x upon cos x that will become tan x. that is x tan x, and that's why you will have, that is the dy by dx is equals to y into these 2 get cancelled, that is a 3 in bracket x plus 2 upon x square plus 2x plus 2 minus 3 upon 2 root x in bracket root x plus 3 minus log of cos x plus x tan x, and after simplification you will get, that is the dy by dx is equals to x square plus 2x plus 2 raised to 3 by 2 root x plus 3 bracket cube into cos of x raised to x in bracket 3 in bracket x plus 1 upon x square plus 2x plus 2 minus 3 upon 2 root x in bracket x plus 3 minus log of cos x plus x times tan x, and this is the answer. Sometimes it is difficult to manage the screen of my laptop. Now the fifth example, x raised to 5 tan cube 4x upon sin square 3x. X raised to 5 into tan cube 4x upon sin square 3x. Take log on both sides. Therefore, log of y is equals to log of x raised to 5 log of tan raised to 3 4x tan cube of 4x minus log of sin square 3x, that is 5 log x plus 3 log of tan of 4x minus 2 log of sin of 3x. Now differentiate this with respect to x. That is 1 upon y into dy by dx. Derivative of log x is a 5 upon x. That is a 3. 1 upon tan of 4x into derivative of tan of 4x is a sec square 4x into ddx of 4x is 4. 2 upon 1 upon sin of 3x into derivative of sin of 3x is a cos of 3x into ddx of 3x is 3. Therefore 1 upon y, that is the dy by dx is equals to y into 5 upon x plus, this is the 3 upon 3 into 4 upon tan of 4x cos square 4x minus 6 cos upon sin, that is the cot of 3x. Now simplify this. This will become, that is a sin of 8x and its reciprocal cosec 8x. Sin 2 sin of 4x into cos of 4x. That is y is equals to y in bracket 5 upon x plus 24 upon sin of 8x minus 6 cot of 3x. Therefore dy by dx is equals to x raised to 5 tan cube 4x upon sin square 3x in bracket 5 upon x plus 24 upon 24 into cosec 8x minus 6 cot of 3x. This is the answer. See this again. So y, take log, normal simplification is here. 1 upon x, 1 upon tan of 4x, it's a derivative. Here is a 1 upon sin of 3x, it's a derivative. Derivative of 3x is again 3. dy by dx is equals to 5 upon x plus 3 into 4, 12. Tan of 4x into cos square 4x minus 6 cot of 3x. Again simplification. Adjust here to 5 upon x, 12 into 2, 24 upon sin of 8x minus 6 cot of 3x and that's for dy by dx is equals to. This is the answer. Now next is sixth one. X raised to tan inverse of x. Now take log on both sides. Therefore, you will get log of y is equals to tan inverse of x, log of x. Differentiate this with respect to x. That is 1 upon y into dy by dx is equals to tan inverse of x. Derivative of log of x is 1 upon x plus log of x into derivative of tan inverse of x is 1 upon 1 plus x square. Therefore, dy by dx is equals to y into in bracket tan inverse of x upon x plus log of x upon 1 plus x square. Therefore, dy by dx is equals to the value of the y, that is x raised to tan inverse of x, tan inverse of x upon x plus log of x upon 1 plus x square. This is the dy by dx. Now the seventh one, sin x raised to x. Y is equals to sin x raised to x. Take log on both sides. Therefore, you will get log of y is equals to x log of sin x. Differentiate this with respect to x. That is 1 upon y. Apply the product rule. X into derivative of log of x is 1 upon sin x into derivative of sin x is a cos x plus derivative of x is 1 log of sin x, and that's why dy by dx is equals to y into in bracket x cot of x plus log of sin x. Therefore, dy by dx is equals to sin of x whole bracket raised to x in bracket x cot x plus log of sin x. Next is 8th one, sin x and bracket raised to x. Now here differentiate with respect to x. Dy by dx is equals to cos of x raised to x into ddx of x raised to x. Now to find out the derivative of x raised to x, here ddx of x raised to x we have find out before this, that is ddx of u. But what is u? U is equals to x raised to x. Take log on both sides. That is the log of u is equals to x log x. Therefore, differentiate this with respect to x, 1 upon u into du by dx. Now apply here product rule, x into log x. What is the derivative of log x? Derivative of log x is 1 upon x plus derivative of x is 1 into log x. X get cancel. That is 1 plus log x. Therefore, du by dx is equals to u into in bracket 1 plus log x, and du by dx is equals to x raised to x in bracket 1 plus log x, and that's the answer. Substitute the value. Put in 1, dy by dx is equals to cos of x raised to x into x raised to x in bracket 1 plus log x. This is the dy by dx. The answer. Cos of x raised to x into x raised to x in bracket 1 plus log x. Dx is equals to tan inverse of x. Next is log of y is equals to tan inverse of x into log of x. Differentiate this. We have completed this. Dy by dx. Sin of x raised to x. Again, this is summarize all these problems. This is the problem. Therefore, du by dx is equals to x raised to x in bracket 1 plus log x. Put in 1, and that's why dy by dx is equals to cos of x raised to x into x raised to x into in bracket 1 plus log x. Now the next is now the question number 2. Differentiate the following with respect to x. X raised to e plus x raised to x plus e raised to x plus e raised to e. Now here one derivative, that is x raised to x, is important. By using log we can find out its derivative. Otherwise all the differentiations are very easy. Dy by dx is equals to e into x raised to e minus 1 ddx plus ddx of x raised to x. Derivative of e raised to x is e raised to x and derivative of e raised to e is 0. It is a constant. Now we will find out the derivative of ddx of x raised to x. Now just we have find out the number of the times its a derivative is, that is a du by dx is equals to x into, that is x raised to x in bracket 1 plus log x. This we have find out the number of the times. That's why you can understand this. That is the ddx of x raised to x is x raised to x in bracket 1 plus log x. Now I will substitute the value. Therefore dy by dx is equals to e into x raised to e minus 1 x raised to x in bracket 1 plus log x plus e raised to x. Now the next is second x raised to x raised to x plus e raised to x raised to x. Y is equals to u plus v. Therefore dy by dx is equals to du by dx plus dv by dx. By differentiating with respect to x, therefore u is equals to x raised to x. Take log on both sides, that is the log of u is equals to x raised to x into log x. Now differentiate this with respect to x. Derivative of log of u is 1 upon u into du by dx. X raised to x into ddx of log x is 1 upon x plus log of x into ddx of x raised to x. Now I will again substitute the value of derivative of x raised to x, that is x raised to x in bracket 1 plus log x. Therefore du by dx is equals to u in bracket x raised to x upon x plus log of x into in ddx of x raised to x. Therefore du by dx is equals to ddx of x raised to x, that is equals to w is equals to x raised to x, take log on both sides, That is the log of w is equals to x into log x, not w. That is 1 upon w dw by dx. Again here we will apply the product rule. That is 1 upon w dw by dx, x into 1 upon x plus 1 into log x. Therefore dw by dx is equals to w in bracket 1 plus log x, and w is x raised to x. Substitute the value. You will get the answer. Therefore du by dx is equals to x raised to x raised to x. X raised to x raised to x, x raised to x upon x plus the x raised to x log of x in bracket 1 upon therefore du by dx is equals to x raised to x raised to x. If you take x raised to x as a common, then log of x du by dx is equals to x raised to x raised to x into x raised to x log x in bracket 1 upon x log x plus 1 plus log x. Therefore du by dx is equals to x raised to x raised to x, x raised to x log of x in bracket 1 upon x log x that is 1 plus log x plus 1 upon x log x. Now the next is v is equals to e raised to x log of v is equals to x raised to x and log of e to the base e is 1. Now differentiate this with respect to x, that is 1 upon v du by dx. Now ddx of x raised to x. Now here we will substitute the value of x raised to x directly. Therefore dv by dx is equals to v into x raised to x in bracket 1 plus log x. And the final is, that is a dv by dx is equals to e raised to x in bracket x raised to x into 1 plus log x. This is the dv by dx. I will show this answer. Number of the times x are there. Therefore dy by dx is equals to x raised to x into x raised to x into log of x in bracket 1 plus log x plus 1 upon x log x plus e raised to x into x raised to x in bracket 1 plus log x. Now see these two answers. This was the first, e into x raised to e minus 1 x raised to x e raised to x. ddx of x raised to x is x raised to x in bracket 1 plus log x, and dy by dx is equals to e into x raised to e minus 1 plus x raised to x in bracket 1 plus log x plus e raised to x. Now this was the problem that is y is equals to u plus v. Differentiate this du by dx plus dv by dx. Now here u is equals to x raised to x raised to x. Take log on both sides. Log of u is equals to x raised to x into log x. Now differentiate this with respect to x. 1 upon u into du by dx. X raised to x. Derivative of log of x is 1 upon x plus log of x and ddx of x raised to x. Now here u in bracket x raised to x upon x plus log of x ddx of x raised to x. Now what is the derivative of x raised to x? That is x raised to x is w. Take log on both sides. That is the log of w is equals to x log x. Differentiate dw by dx. That is the w into this x z cancel 1 plus log x and w is equals to x raised to x. Therefore du by dx is equals to x into x raised to x upon x plus log x plus x into that is log of x into x raised to x in bracket 1 plus log x. And that's why the final is, if we take x raised to x as a common, then overall you will get du by dx is equals to x raised to x into x raised to x into log x in bracket 1 upon x log x plus 1 plus log x. And sequentially we can write it x raised to x into x raised to x log of x bracket 1 plus log x plus 1 upon x log x. Next is v is equals to e raised to x log of v x raised to x log of v. Log of v is equals to x raised to x. Log of v means what? 1 upon v into dv by dx. ddx of x raised to x. The derivative of x raised to x is dv by dx is equals to v into x raised to x. The derivative of x raised to x. The derivative of x raised to x is x raised to x in bracket 1 plus log x. Therefore here we are substituting dv by dx is equals to e raised to x into x raised to x in bracket 1 plus log x. And that's why we get the answer. That is the dy by dx is equals to x raised to x into x raised to x into log x in bracket 1 plus log x plus 1 upon x log x plus e raised to x into x raised to x into in bracket 1 plus log x. Now the next is third, log of x raised to x minus cos. The third problem is missed by me. That is fourth one. X raised to e raised to x plus log of x raised to sin x. Therefore u is equals to x raised to e raised to x and v is equals to log of x bracket raised to sin x. Therefore take log on both sides. That is the log of u is equals to e raised to x into log x and log of v is equals to sin x log of log x. Now differentiate this with respect to x. Therefore 1 upon u into du by dx e raised to x into log x. Log of x derivative 1 upon x e raised to x. Derivative of e raised to x is e raised to x into log x plus 1 upon v dv by dx sin x. Log of log x is 1 upon log x into derivative of log of x is 1 upon x. Therefore, and into the next is the derivative of sin is cos x into log of log x. Therefore, du by dx is equals to u into in bracket e raised to x upon x plus e raised to x into log x. And dv by dx is equals to v into sin x upon x log x plus cos x log of log x bracket complete. Therefore, y is equals to u plus v. Then it's a dy by dx is equals to du by dx plus dv by dx. Therefore, we will substitute the values. That is a dy by dx is equals to x into e raised to x in bracket e raised to x upon x plus e raised to x into log x that is the log of x raised to sin x in bracket sin x upon x log x plus cos x into log x log of log x bracket complete, and this is the dy by dx. That is x raised to e raised to x into e raised to x into e raised to x. If we take e raised to x as common, then in bracket 1 upon x plus log x that is the log of x raised to sin x upon x log x plus cos x into log of x bracket complete. This is the answer. Now again see this here. There was one mistake in this problem. I had a mistake. That is the log of third problem. That is the log of x raised to x and minus cos of x bracket raised to cot x. Y is equals to. Now when I am taking here log by mistake, I cannot change now. I can change afterward this. That is the log of u. Here is a x into log of log x must be there, and that's why the answer is different one. Let it be. You can solve this example. And what about the here? That is v is equals to cos of x raised to cot x takes log on both sides, and this one is the correct one. That is the log of v is equals to cot x into log of cos x. Differentiate 1 upon v dv by dx cot of x 1 upon cos x, and derivative cos x is sin x, and that's why you will get this sin upon cos, that is a tan, minus cot into tan, that is a minus 1, and here is a minus log of cos x into cos x square x. This is, and take minus sign, and overall this is correct one, but in this case I added a mistake. Therefore you solve when you have the time. Now I will show the current example. This is our example. That is x raised to e raised to x plus log of x raised to sin x. U is equals to x raised to e raised to x, and v is equals to log of x raised to sin x. Now take log on both sides, differentiate with respect to x, 1 upon u du by dx. Apply the product rule, e raised to x, derivative of log of x is 1 upon x, e raised to x, derivative of e raised to x is e raised to x into log x. Log of e, its derivative is 1 upon v dv by dx is equals to sin x, derivative of log x is 1 upon log x into derivative of log of x is 1 upon x. Next is derivative of sin x is cos x into log x, and solve this. That is a du by dx is equals to u into e raised to x upon x plus e raised to x into log x, and dv by dx is equals to v into in bracket sin x upon x log x plus cos x into log x, and that's why also y is equals to u plus v. Substitute the values of these with u is equals to x raised to e raised to x upon x plus e raised to x log x plus log of x bracket raised to sin x upon x log x plus cos of x into log of cos x, and this is the answer. Now next is this is your dy by dx. I will see the next problem. Fifth problem, that is e raised to tan x plus log of x raised to tan x. Now again u plus v, u is equals to e raised to tan x and v is equals to log of tan x. V is equals to log of x and bracket raised to tan x. Now differentiate this with respect, again with respect to x. Here do not require to take the log. Du by dx is equals to e raised to tan x into derivative of tan x is sec square x. That is a e raised to x into sec square x. Now here we will take the log. That is log of v is equals to tan of x log of log x. Now here I am taking the double log. Differentiate this with respect to x, 1 upon v dv by dx and apply the product rule. Tan of x as it is. Derivative of log x is 1 upon log x into derivative of log of x is 1 upon x. Log of log x and derivative of tan x is sec square x. Therefore, dv by dx is equals to v into tan of x upon x log x plus log of log x into sec square x. Substitute the value of v log of x raised to tan x upon x log x plus log of log x into sec square x. Therefore, dy by dx is equals to du by dx plus dv by dx which is sec square into e raised to tan x plus log of x raised to tan x in bracket tan of x upon x log x plus sec square x into log of log x. See this again here. Fifth one. This is u and v, their differentiation. Du by dx is equals to e raised to tan x into sec square x and dv by dx is equals to v into tan of x upon x log x plus log of log x into sec square x. Therefore, dv by dx is equals to log of x bracket is to tan x in bracket tan of x upon x log x plus log of log x into sec square x. And this is the final answer. Now next is sin of x raised to tan x plus cos of x raised to cot x. Now here u is equals to sin of x raised to tan x and v is equals to cos of x raised to cot x. First of all, let y u is equals to sin of x raised to tan x and v is equals to cos of x raised to cot x. Take log on both sides. That is, log of u is equals to tan of x log of sin x. Log of v is equals to cot of x log of cos x. Now differentiate this with respect to x. Therefore, 1 upon u du by dx tan of x log of sin x 1 upon sin x into derivative of sin x is cos x. By mistake it is a cot. This is the cos. Derivative of tan is a sec square x into log of sin x. Now here is a cos x upon sin x, that is a cot x. Tan of x into cot x plus sec square x into log of sin x. That is a 1 plus sec square into log of sin x. Therefore, du by dx is equals to u in bracket 1 plus sec square x into log of sin x. Substitute the value of u. That is sin x raised to tan x 1 plus sec square x into log of sin x, bracket complete. Now the next is log of v is equals to cot of x into log of cos x. Now differentiate this with respect to x. 1 upon v into dv by dx. Apply the product rule. Derivative of cot is minus cos x square x log of cos x plus cot x. Derivative of log of cos x is 1 upon cos x into derivative of cos x is minus sign. And therefore dv by dx is equals to v into in bracket minus cos x square x into log of cos x minus cot x into tan x. That get cancelled, you will get minus 1 there. Therefore, dv by dx is equals to cos of x raised to cot x minus cos x square into log of cos x minus 1. And therefore, dy by dx is equals to dy by dx is equals to sin of x raised to tan x in bracket 1 plus sec square x into log of sin x plus there is a plus sign. Now we'll check, that is minus cos of x raised to cot x in bracket 1 plus cos x square x into log of cos x. We'll see this answer. This is the sixth one. It's a derivative. U is equals to v is equals to du 1 upon u du by dx tan 1 upon sin into cos. The cos upon sin, that is a cot 1. This is the du by dx. Now what about here? Here is a derivative of cot, which is a minus cos square x log of cos x. It's a minus, take minus sign as common, and that's why it's a minus sign is there. That is a cos of x raised to cot x. But in the textbook, the answer is wrong. I think that there is a minus sign must be there. Now the next is 7 10 raised to x plus x raised to 10 plus x raised to 10 raised to x. Now y is equals to UVW. Now u is equals to x raised to x. Now this is the seventh one, that is u is equals to 10 raised to x, v is equals to x raised to 10, and w is equals to x raised to 10 raised to x. U is equals to 10 raised to x. Take log on both sides. Log of u is equals to x raised to x log of 10. Therefore, differentiate this with respect to 1 upon u du by dx. Log of 10 ddx of x raised to x. Therefore, du by dx is equals to u into log of 10, and derivative of x raised to x is very common now. X raised to x in bracket 1 plus log x. That's we have solved number of the times. In exam you must solve that. Therefore, du by dx is equals to 10 raised to x log of 10 in bracket x raised to x in bracket 1 plus log x du by dx is equals to 10 raised to x log of 10 x raised to x log of 10 in bracket 1 plus log x. Next is v is equals to x raised to 10. If we take log on both sides, that is log of v is equals to x raised to 10 log x. 1 upon differentiate this with respect to x. 1 upon v dv by dx. 9 in, that is a 10 into x raised to 9 into log of x plus x raised to 10 derivative of log of x is 1 upon x. Therefore, dv by dx is equals to v into 10 into x raised to 9 log of x plus x raised to 9. Therefore, dv by dx is equals to x raised to 10. 10 x raised to 9 log of x plus x raised to 9. Take x raised to 9 as a common. And this is the dv by dx. Now w. W is equals to, now here w is equals to x raised to 10 raised to x. Take log on both sides. Therefore, log of w is equals to 10 raised to x into log of x. Now differentiate this with respect to x. Therefore, 1 upon w into dw by dx. Now here we will apply the product rule. 10 raised to x derivative of log of x is 1 upon x plus log of x into derivative of 10 raised to x means what? 10 raised to x into log of 10. Therefore, dw by dx is equals to w in bracket 10 raised to x upon x plus 10 raised to x log of x log of 10. Therefore, x raised to 10 raised to x in bracket 10 raised to x upon x plus 10 raised to x into log of x into log of 10. Therefore, 10x raised to 10 raised to x into log of into 10 raised to x in bracket 1 upon x plus log of x into log of 10. Therefore, dwy. Therefore, from 1, 2 and 3, that is 10 raised to x into x raised to x into log of 10 in bracket 1 plus log of x plus x raised to 10 into x raised to 9 in bracket 1 plus 10 log x plus x raised to 10 raised to x log into 10 raised to x in bracket 1 upon x plus log of x into log of 10. Therefore, you can see this also. U phi w v is equals to x raised to 10. Differentiate it. W is equals to x raised to 10 raised to x and therefore from 1 to 3 this is the final answer. That is a 10 raised to x raised to x into x raised to x log of 10 in bracket 1 plus log x plus x raised to 10 x raised to 9 in bracket 1 plus 10 log x. Next is x raised to 10 raised to x into 10 raised to x in bracket 1 upon x plus log of x into log of 10. Now next problem. Tan of x raised to tan x in whole bracket raised to tan x at x is equals to pi by 4. Let y is equals to tan x raised to tan x and whole bracket raised to tan x. U is equals to tan x whole bracket raised to tan x. Therefore, y is equals to u raised to tan x. Now, u is equals to tan x raised to tan x. Now differentiate this. Take log on both sides. Log of y is equals to tan x log of u. Here is also log of u is equals to tan x into log of tan x. Differentiate this. With respect to x, 1 upon y into dy by dx is equals to tan x. Log of u is 1 upon u into du by dx. And same is here, that is 1 upon u du by dx tan x. Derivative of log of tan x is 1 upon tan x into sec square x plus log of tan x into derivative of tan x is a sec square x. Here is again y into tan of x, 1 upon tan of x raised to tan x into du by dx. Therefore dy by dx is equals to y into tan x into 1 upon tan of x raised to tan x into du by dx. This is the du by dx. Therefore du by dx is equals to u into sec square x in bracket 1 plus log of tan x therefore du by dx is tan of x raised to tan x into sec square x in bracket 1 plus log of tan x. Therefore dy by dx is equals to the final answer. Hello student, before we start the example number 8, we will see the third examples. That was I had made the correction in that example. What was that example? That is log of x raised to x minus cos of x raised to cot x. Y is equals to log of x raised to x minus cos of x raised to cot x. Y is equals to u minus v. U is equals to log of x raised to x. V is equals to cos of x raised to cot x. Take log on both sides. Then you will get log of u is equals to x into log of log x. This I was forget. Now differentiate this with respect to x. Then 1 upon u du by dx is equals to x into derivative of log x. That is 1 upon log x into 1 upon x plus x. The derivative of x is 1 log x. And that's why du by dx is equals to u into this x get cancelled. You will get u into in bracket 1 upon log x plus log x. Therefore, this is your du by dx. At the same time, we will see the derivative of v. That v is equals to cos of x raised to cot x. Take log on both sides. Then you will get log of v is equals to cot of x into log of cos x. Now differentiate this with respect to x. Then you will get that is 1 upon v into dv by dx is equals to cot of x into the derivative of log of cos x. That is 1 upon cos x into derivative of cos of x is the minus sin x. And that's why you will get that is a sine upon cos, that is a tan. That is a minus cot x into tan x, that's equals to minus 1. And next is a, that is the log of cos x, and the derivative of cot x is the minus cos x square x. And therefore dv by dx is equals to cot of x, cos of x raised to cot x minus 1 minus log of cos x into cos x square x, and hence this is the dy by dx. Now in this case, if you take the minus sign common, and that minus minus will become plus. That is, in the textbook it's a given that the answer is log of x raised to x in bracket 1 plus log of x raised to and therefore this is the final answer. That is the dy by dx is equals to log of x raised to x in bracket 1 plus 1 upon log x plus log of log x plus cos of x raised to cot x in bracket 1 plus log of cos of x into cos x square x. Now we'll start the next example. And this is the example number 8. That is the tan of x raised to tan of x raised to tan of x at x is equals to pi by 4. Let y is equals to tan of x raised to tan of x and bracket raised to tan x. U is equals to tan of x raised to tan x. Therefore, y is equals to u raised to tan x. Now take log on both sides. That is the log of y is equals to tan of x into log of u. Now differentiate this. That is 1 upon y dy by dx tan of x into, that is a 1 upon u into du by dx. Therefore this dy by dx is equals to y into tan of x upon u into du by dx plus sec square x into log of u. At the same time, here is a u is equals to tan of x raised to tan x. Take log, that is a log of u is equals to tan of x into log of tan x. Now differentiate this, that is 1 upon u into du by dx is equals to tan x. Log of tan of x, its a derivative is 1 upon tan x into derivative of tan is a sec square x. And that's why this tan get cancelled. Then you will get, that is a, this is the sec square x and plus log of tan of x into sec square x. Now see this is the dy by dx, which is the y into tan of x upon tan of x raised to tan x into du by dx plus sec square x into log of tan of x raised to tan x. This is now in this case we'll first find the value of the du by dx. Now what is this? That is the du by dx is equals to u into sec square x plus sec square into log of tan x. Therefore du by dx is equals to u into sec square x. Take sec square common and at the x is equals to pi by 4. Then you will get tan of pi by 4. Here is a tan of pi by 4. Sec square pi by 4 in bracket 1 plus log of tan of pi by 4. And if we substitute all these values, that is the tan of pi by 4 is 1 raised to 1. Sec square pi by 4, that is a root 2 square. And next in bracket 1 plus log of tan of pi by 4. This is the log of 1 and log of 1 is 0. And overall, it's a 1 root 2 square. This is a 2, 1 plus 0. And overall, you are getting the du by dx at x is equals to pi by 4 is a 2. Now substitute this value here. This is our dy by dx, the whole term is, and I had not substituted the value of the du by dx. I will substitute direct value. This is the 2 here. And at x is equals to pi by 4. Again here, put tan of pi by 4 is 1. This is tan of pi by 4 1. This tan of pi by 4 is 1. And the tan, this is 1 raised to 1 into 2 root 2 square, and it is into log of 1. What is log of 1? Log of 1 is a 0, and overall this quantity becomes 0. That is 1 upon 1 into 2, and overall you are getting its value is a 2. Therefore at x is equals to pi by 4, its value is a 2. Now we'll start the question number 3. Find dy by dx if root x plus root y is equals to root a. The derivative of root x is 1 upon 2 root x, and derivative of root of y is 1 upon 2 root of y into dy by dx is equals to 0. Therefore 1 upon 2 root y into dy by dx is equals to minus 1 upon 2 root x. Therefore dy by dx is equals to, these 2 to get cancelled, then you will get dy by dx is equals to minus root of y upon root x. The next example. Again you can see this here also. This is the find dy by dx if root x plus root y is equals to root a, differentiate with respect to x. 1 upon 2 root x plus 1 upon 2 root y into dy by dx. Therefore 1 upon 2 root y into dy by dx is equals to minus 1 upon 2 root x. Therefore dy by dx is equals to minus root y upon root x, and that's why dy by dx is equals to minus root of y upon x. Now the next is x root x plus y root y is equals to a root a. Now x root x means what? X raised to 3 by 2 plus y raised to 3 by 2 is equals to a root a. Differentiate this with respect to x. Therefore it is 3 by 2, x raised to 1 upon 2, 3 by 2 into y raised to 1 upon 2 into dy by dx. Derivative of a root a, that is 0, and that's why dy by dx is equals to minus x raised to 1 upon 2 upon y raised to 1 upon 2, and that is nothing but the minus in root of y, x upon y. Again you can see this here. This is the x root x plus y root y is equals to a root a. X raised to 3 by 2 plus y raised to 3 by 2 is equals to a root a. Differentiate this with respect to x. 3 by 2 into x raised to 1 upon 2 plus 3 by 2 y raised to 1 upon 2 into dy by dx is equals to 0. And hence the dy by dx is equals to, now this is a minus x raised to 1 upon 2 upon y raised to 1 upon 2, that is the minus in root of x upon y. Therefore dy by dx is equals to in root of x upon y. Now next is third example, x plus in root of xy plus y. Derivative of x is 1. Next is the derivative of root of xy, that is 1 upon 2 root xy into derivative of xy. Derivative of x is 1 into y plus x into derivative of y is dy by dx plus derivative of this y is a dy by dx. Then simplify. This is 1 plus 1 upon plus this 1 upon 2 root xy into y, that is y upon 2 root xy plus 1 upon 2 root xy into x into dy by dx, that is you will get x upon 2 root xy into dy by dx plus dy by dx, that is equals to 0. into dy by dx plus dy by dx is equals to 0. Therefore, one plus, now this is y and this is a root y. Therefore, root y upon root x, that is what root of y upon 2 root x. It is also root x upon 2 root y into dy by dx plus dy by dx is equals to 0. Take dy by dx as a common and simplify this. That is a 1 plus root of y. Normal simplification is here. That is 1 plus root of y upon 2 root x multiplied with this one. Then you will get 2 root x plus root y upon 2 root x plus simplification of this is take dy by dx as common, then root x upon 2 root of y plus 1 and then root x plus 2 root of y upon 2 root of y bracket complete into dy by dx is equals to 0 and we can solve that example. Therefore, that is on the right hand side, this is a minus 2 root x plus root y upon 2 root x and that's why dy by dx is equals to minus 2 root x plus root y upon 2 root x. Simplify this upon root x upon root x plus 2 root y upon 2 root of y. Therefore, dy by dx is equals to minus 2 root x plus root y upon 2 root x into 2 root y upon root x plus 2 root y. The terms get cancelled and you will get the dy by dx is equals to minus root y upon root x in bracket 2 root x plus root y upon root x plus 2 root y, and this is the answer. See this. Next is this is x plus is root of xy plus 5. Differentiate root of xy 1 upon 2 root of xy and the derivative of xy. Derivative of x is 1y plus x into derivative of y is dy by dx bracket complete plus dy by dx is equals to 0. Now 1 plus, that is a y upon 2 root of xy plus 1 upon 2 root of x, that is x upon 2 root of xy. Then again here is a 1 power and then it will become root x upon 2 root y into dy by dx plus dy by dx is equals to 0. Take the dy by dx as a common and simplify it and then you will get the answer. Now the next is number 4, x cube plus x square y plus xy square plus y cube is equals to 81. Now differentiate this with respect to x. 3x square plus, now the derivative of this product rule, that is x square, is a 2x into y plus x square into dy by dx. Again x into y square, derivative of x is 1 into y square plus x into y square. The derivative of y square is a 2y into dy by dx plus 3y square into dy by dx is equals to 0. Now it's a derivative. That is a 3x square 2xy plus y square. These are the terms. That is a 3x square plus 2xy plus y square. Next is the terms of the collect the terms of the dy by dx. that is x square into dy by dx plus 2xy into dy by dx plus 3y square into dy by dx, that's equals to 0. We collect it, therefore dy by dx is equals to minus 3x square plus 2xy plus y square upon x square plus 2xy plus 3y square that is the dy by dx is equals to 3x square plus 2xy plus y square. Now see this again here. Answer x cube 3x square into y, that is the derivative of x square is a 2x into y plus derivative of y is a dy by dx plus derivative of x is 1 and y square plus x into derivative of y square is a 2y into dy by dx plus derivative of y cube, that is a 3y square into dy by dx. Now collect the terms of the dy by dx and you will get the answer. Now the next is fifth one, x square into y square minus tan inverse of x square plus y square is equals to cot inverse of in root of x square plus y square. Therefore x square into y square is equals to tan inverse of in root of x square plus y square plus cot inverse of in root of x square plus y square. Now this is very important formula, that is the tan inverse of theta plus cot inverse of theta is equals to pi by 2, and that's why we got this x square into y square is equals to pi by 2. Now differentiate this with respect to x. Derivative of x square is a 2x into y square plus x square into derivative of y square is a 2y into dy by dx equals to 0. And that's why x square into 2y into dy by dx is equals to minus x into, now this 2 get cancelled by mistake, and again multiplying with by 2. Therefore dy by dx is equals to minus 2xy square upon x square into 2y. And that's why dy by dx is equals to minus y upon x. Next is, see this again. This is the x square into y square minus tan inverse in root of x square plus y square is equals to cot inverse in root of x square plus y square. That is x square into y square is equals to tan inverse in root of x square plus y square plus cot inverse in root of x square plus y square. And by using the formula, that is the tan inverse of theta plus cot inverse of theta is equals to pi by 2, and differentiate this. Apply the product rule, derivative of x square is a 2x y square plus x square, derivative of y square is a 2y into dy by dx, and simplify it. Then you will get the answer. This is very simple. Dy by dx is equals to minus y upon x. Now the next is 6. X into e raised to y plus y into e raised to x is equals to 1. Now differentiate this with respect to x. Derivative of x is 1 into e raised to y into e raised to x, apply the product rule. That is x into e raised to y into dy by dx plus y into, both of them have the product rule. See this again. Derivative of x is 1 e raised to y. X as it is, derivative of e raised to y is e raised to y into dy by dx plus y into e raised to x. Derivative of y is a dy by dx, keep e raised to x as it is, plus y as it is, derivative of e raised to x is e raised to x, and derivative of 1 is 0. Take the terms of the dy by dx as a common, that is x into e raised to y plus e raised to x into dy by dx is equals to minus e raised to y plus y into e raised to x. Therefore, dy by dx is equals to minus e raised to y into e raised to x upon x into e raised to y plus e raised to x. This is the answer. That is a 10 raised to 7th one. E raised to x plus y is equals to cos of x minus y. Now differentiate this with respect to x. Derivative of e raised to x plus y is e raised to x plus y. And x plus y, derivative of x plus y, ddx of x plus y is equals to derivative of cos of x minus y, that is a minus sin x minus y into ddx of x minus y. E raised to x plus y, derivative of x is 1, derivative of y is a dy by dx is equals to minus sin of x minus y into derivative of x is 1, y is a minus dy by dx. Collect the terms of the dy by dx on one side, that is e raised to x plus y, 1 into e raised to x plus y into dy by dx, that is e raised to x plus y into dy by dx, that is minus sin into 1 and again this dy by dx. Now collect the terms of the dy by dx on one side, that is sin of x minus y into dy by dx minus e raised to x plus y into dy by dx. Collect the term of the dy by dx. Therefore, sin of x minus y minus e raised to x plus y into dy by dx is equals to e raised to x plus y plus sin of x minus y. Therefore, dy by dx is equals to e raised to x plus y plus sin of x minus y upon sin of x minus y minus e raised to x plus y. Therefore, dy by dx is equals to e raised to x plus y plus sin of x minus y upon sin of x minus y minus e raised to x plus y. Next is 8th one. Cos of xy is equals to x plus y. Now differentiate this with respect to x. Cos of x y is equals to, its derivative is a minus sin of xy into ddx of xy. Therefore, I will show this example. Now see this here. This is the 6th one. Differentiate with respect to x. Derivative of x is 1 into e raised to y plus x into derivative of e raised to y is e raised to y into dy by dx plus y into e raised to x. Derivative of y is a dy by dx and this is the e raised to x plus y into derivative of e raised to x is equals to 0. Now collect the term of this dy by dx. And that's why this the same thing. Okay. Collect the terms of this dy by dx, that x into e raised to y plus e raised to x into dy by dx is equals to minus in bracket e raised to y plus y into e raised to x. Therefore, dy by dx is equals to minus in bracket e raised to y plus y into e raised to x upon x into e raised to y plus e raised to x. And this is the answer. Now the next is Therefore dy by dx is equals to 1 plus y sin xy upon 1 plus x sin xy. Now the next example. E raised to x minus y is equals to x upon y. Here is a y into e raised to x minus y is equals to x. Take log on both sides. Then you will get log of y plus log of e raised to x minus y is equals to log x. Therefore log of y, e raised to x minus y into log of e to the base e, and that is a log of x. Now this value is a 1. Differentiate with respect to x, 1 upon y into dy by dx plus e raised to x minus y into derivative of x minus y. Derivative of x is 1. Dx of x minus y. Derivative of x is 1. Derivative of y is a dy by dx, 1 upon x. Multiplication, here is it. Collect the terms of the dy by dx, that is 1 upon y plus e raised to x minus y. These two terms, that is 1 upon y minus into dy by dx minus e raised to x minus y into dy by dx, that is equals to 1 upon x minus e raised to x minus y. Take dy by dx as a common, that is 1 upon y minus e raised to x minus y into dy by dx is equals to 1. This is simplification, 1 minus x into e raised to x minus y upon x. Again this is also simplification, that is 1 minus y into e raised to x minus y upon y, and that's why you will get the dy by dx is equals to y upon x into 1 minus x into e raised to x minus y upon 1 minus y into e raised to x minus y. Therefore dy by dx is equals to y in bracket 1 minus x into e raised to x minus y upon x in bracket 1 minus y into e raised to x minus y. Next is number 10. X plus sin of x plus y is equals to y minus cos of x minus y. That is x plus sin of x plus y is equals to y minus cos of x minus y. Now differentiate this with respect to x. Derivative of x is 1. Sin of x plus y is a cos of x plus y into ddx of x plus y. Derivative of y is dy by dx, and derivative of cos of x minus y is a minus, and this minus minus will become plus. That is sin of x minus y into ddx of x minus y. That is 1 plus cos of x plus y. ddx of x plus y, derivative of x is 1 and y is a dy by dx, is equals to dy by dx plus sin of x minus y into ddx of x minus y, derivative of x is 1 and y is a dy by dx. Now collect the terms of dy by dx. That is 1 plus cos of x plus y plus cos of x plus y into dy by dx is equals to dy by dx plus sin of x minus y into 1 minus sin of x minus y into dy by dx. Collect all the terms of the dy by dx, that is 1 plus cos of x plus y minus sin of x minus y. Therefore dy by dx single term minus cos of x plus y into dy by dx minus sin of x minus y into dy by dx. Collect all the terms of the dy, 1 minus cos of x plus y minus sin of x minus y bracket complete into dy by dx. Therefore dy by dx is equals to 1 plus cos of x plus y minus sin of x minus y whole divided by 1 minus cos of x plus y minus sin of x minus y, and this is the answer. Therefore divide by, or you can solve this also, that is the divide by. It is written as like this. This is the answer. Now see this, if you want to see once again, revise this. E raised to x plus y is equals to cos of x minus y, differentiate with respect to x. E raised to x plus y into dy by dx, ddx of x plus y minus sin of x minus y into ddx of x minus y. Differentiate this ddx of x plus y, derivative of x is 1 and y is a dy by dx, minus sin in bracket minus sin x minus y into ddx of x minus y, derivative of x is 1 and y is a dy by dx. Collect the terms of the multiplication, that is e raised to x plus y plus e raised to x plus y into dy by dx minus sin of x minus y plus this minus minus will become plus sin of x minus y into dy by dx. Now collect the terms of this dy by dx, that is e raised to x plus y plus sin of x minus y is equals to sin of x minus y into dy by dx minus e raised to x plus y into dy by dx. If you collect the terms of the dy by dx, then you will get sin of x minus y minus e raised to x plus y into dy by dx is equals to e raised to x plus y plus sin of x minus y, and that's why you will get the dy by dx is equals to e raised to x plus y plus sin of x minus y upon sin of x minus y minus e raised to x plus y. This was the example. Now next is 8th one, that is the cos of xy is equals to cos of x plus y. Differentiate this again with respect to x and revise these examples once again. That is the derivative of cos of x plus cos of xy is a minus sin of xy, ddx of xy. That is the derivative of x is 1, y, then x as it is, derivative of y is a dy by dx. Next is 1 plus dy by dx, and again multiplication. Collect the terms of the dy by dx. Revise this all these examples, whatever that we have solved, and you will get the dy by dx. In the same way, example number 9, that is a y into e raised to x minus e raised to x minus y. Take log on both sides, log of y plus log of e raised to x minus y is equals to log x. Therefore, log of y plus e raised to x minus y, log of e to the base e is 1. Again differentiate this, therefore you will get the answer. Finish all these examples. Now the 10th one, that x plus sin of x plus y minus is equals to y minus cos of x plus y. Differentiate again, derivative of x is 1, sin of x plus y, cos of x plus into ddx of x plus y. Same manner, the right hand side, y is a dy by dx minus cos of x minus y is a plus sin of x minus y, ddx of x minus y, and collect the terms of again cos of x plus y. Derivative of x is 1, derivative of y is a dy by dx. Again derivative of x is 1, derivative of y is a dy by dx. Multiplication. Here is collect the terms of the dy by dx very accurately. This is the terms the dy by dx. Therefore dy by dx is equals to 1 plus cos of x plus y minus sin of x minus y upon 1 minus cos of x plus y minus sin of x minus y, or you may write like this also. Now the next examples are through that. Question number 4. Show that dy by dx is equals to y upon x in the following, where a and p are the constants. First, x raised to 7 into y raised to 5 is equals to x plus y bracket raised to 12. Take log on both sides. Log of x raised to 7 plus log of y raised to 5 is equals to 12 in bracket 12 into log of x plus y. Differentiate, that is a 7 log x plus 5 log of y is equals to 12 log of x plus y. Differentiate with respect to x. That is 7 upon x plus 5 upon y into dy by dx is equals to 12 upon x plus y into ddx of x plus y. Derivative of x is 1 and y is a dy by dx. And simplify, then you will get the answer. Therefore, 7 upon x plus 5 upon y into dy by dx is equals to 12 upon x plus y into 1. That is a 12 upon x plus 5 plus 12 upon x plus y into dy by dx. Now collect the terms of the dy by dx. That is 7 upon x minus 12 upon x plus y. That is 7 upon x minus 12 upon x plus y is equals to in bracket 12 upon x plus y minus 5 upon y into dy by dx. Now simplification. That is 7 in bracket x plus y minus 12x upon x into x plus y is equals to 12y minus 5 in bracket x plus y upon y into in bracket x plus y into dy by dx. Now simplify this. Therefore, 7x plus 7y minus 12x upon 12y minus 5x minus 5y is equals to dy by dx. And if we simplify this, therefore, this is the y upon x in bracket 7y minus 5x upon 7y minus 5x is equals to dy by dx. Therefore, dy by dx is equals to y upon x. This is the first we prove here. Now again, see this here. See this here. Differentiate, collect the terms of the dy by dx. Normal simplification is here. And that's why in every examples we will have the answer. That is the dy by dx is equals to y upon x. Now the second example is x raised to p into y raised to 4 is equals to x plus y bracket raised to p plus 4, where p belongs to set of natural number. Take log on both sides. That is a p log x plus 4 log of y is equals to p plus 4 in bracket log of x plus y. Now if we differentiate this, then you will get, that is a log of x is 1 upon x, that is a p upon x. Log of y is a 4 upon y into dy by dx. And the p plus 4 log of x plus y, that is 1 upon x plus y into ddx of x plus y. And therefore you will get, that is a p upon x plus 4 upon y into dy by dx is equals to p plus 4 upon x plus y in bracket derivative of x is 1 and derivative of y is a dy by dx. And next simplification is that is a p upon x minus cross multiplication I will show you this second example. This is the p upon x plus 4 upon y into dy by dx, p plus 4 upon p plus y into ddx of x plus y, p upon x, p plus 4 upon x plus y on the left hand side, and 4 upon y into dy by dx to the right hand side. Take the dy by dx as a common, cross multiplication. Therefore, px plus py minus px minus 4x upon x into x plus y. Now here is again cross multiplication, y into y, p plus 4 minus 4 into x plus y upon y into x plus y into dy by dx. Therefore, x plus y on both sides get cancelled. Therefore, dy by dx is equals to px plus py minus xp minus 4x upon yp plus 4y minus 4x minus 4y. The terms get cancelled, and that's why you are getting that is y upon x into px minus 4x py minus 4x is equals to dy by dx, and that's why dy by dx is equals to y upon x. The same is explained here. Now the terms get cancelled. Y upon x into px minus 4x upon py minus 4x is equals to dy by dx. Therefore, dy by dx is equals to y upon x. Now the next is example number 3. That is sec of x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 is equals to a square. I had not written a square. Whatever that a square, a, these are the again the constant. That is a sec inverse of a, that is equals to p. And we treat that constant as a p. Therefore, x square plus y square upon x square minus y square is equals to p. Cross multiplication, then you will get x square plus y square is equals to p x raised to 5 minus p y raised to 5. On one side, the terms of the y, that is a y raised to 5 plus p y raised to 5 is equals to p x raised to 5 minus x raised to 5. Y raised to 5 is common, 1 plus p, x raised to 5 common, p minus 1. Therefore, y raised to 5 upon x raised to 5 is equals to p minus 1 upon p plus 1. And take the fifth root on both sides, that is a fifth root of p minus 1 upon p plus 1. And again, differentiate this with respect to x. Therefore, ddx of y upon x, apply the quotient rule. On the right hand side, there is a constant, its derivative is 0. Therefore, quotient rule is x into dy by dx minus y into derivative of x is 1 upon x square. If we simplify x into dy by dx minus y is equals to 0, therefore dy by dx is equals to y upon x. Now see this again here. This is not a square. There here must be the a square. You can change it a square. Overall, it is a constant. Cross multiplication. Y raised to 5 upon x raised to 5 is equals to p minus 1 upon p plus 1. Take the fifth root. Differentiate. Apply the quotient rule. that is x into dy by dx minus y into 1 upon x square is equals to 0, and that's why dy by dx is equals to y upon x. Next is fourth one, tan inverse of 3x square minus 4y square upon 3x square plus 4y square is equals to a square. Now 3x square minus 4y square upon 3x square plus 4y square is equals to tan inverse of a square, that is equals to k, or it is p. Therefore 3x square minus 4y square upon 3x square plus 4y square, that is equals to p. Cross multiplication, 3x square minus 4y square is equals to p in bracket 3x square plus 4y square, that is a 3x square minus 3x square into p is equals to 4y square p plus 4y square. Take here 3x square as a common on the another side, 4y square as a common. Then again, that is a 3 in bracket 1 minus p upon 4 in bracket 1 plus p, that is y square upon x square. Take square root on both sides, then you will get y upon x is equals to, or y square upon x square, y square upon x square is equals to 3 in bracket 1 minus p upon 4 in bracket 1 plus p. Take the square root, again apply the quotient rule. The rate of this constant is 0. Same thing is repeated here. Therefore dy by dx is equals to y upon x. Hence proved. See this again. You want to tan inverse, that is p, square root, differentiate with respect to the derivative of this constant is 0. Apply the quotient rule for the y upon x, and that's why dy by dx is equals to y upon x, and hence it is a root. Next is cos inverse 7x raised to 4 plus 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 is equals to tan inverse of a. Again, all these are the constant, that is a 7x raised to 4 plus 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 is equals to cos of tan inverse of a, which is equals to p. Again, make the cross multiplication. That is a 7x raised to 4 plus 5y raised to 4 is equals to p into 7x raised to 4 minus 5y raised to 4. Collect the term of the x square and y x raised to 4 and y raised to 4 on the different sides. Therefore, that is a 5y raised to 4 plus 5py raised to 4 is equals to 7px raised to 4 minus 7x raised to 4. Therefore 5 in bracket 5 plus 5p into y raised to 4 is equals to 7p minus 7x raised to 4. Y raised to 4 upon x raised to 4 is equals to minus that is a 7p minus 7 upon 5p, 5 plus 5p. Take the fourth root. Take the fourth root. On both sides, which is written with the constant. Y upon x is equals to k. Again differentiate this with respect to x. Therefore dy by dx is equals to constant derivative of constant is 0. The same terms are repeated here. Dy by dx is equals to y upon x. Now the next example, before that, see this again here. This is the multiplication. Collect the terms of the x raised to 4 and y raised to 4 on the different side. Take the fourth root. Y upon x is equals to k, differentiate with respect to x, and that's why dy by dx is equals to y upon x. Now next is log of x raised to 20 minus y raised to 20 upon x raised to 20 plus y raised to 20 is equals to 20. Therefore x raised to 20 minus y raised to 20 upon x raised to 20 plus y raised to 20 is equals to e raised to 20. Now this is treated as the p. Make the cross multiplication. X raised to 20 minus y raised to 20 is equals to p in bracket x raised to 20 plus y raised to 20. X raised to 20 minus y raised to 20, p raised is equals to p into x raised to 20 plus p into y raised to 20. Correct the terms of x raised to 20. Therefore, y raised to 20 upon x raised to 20 is equals to 1 minus p upon 1 plus p or p plus 1. Take 20th root, that is y upon x is equals to 20th root of 1 minus p upon 1 plus p. It's a constant. Differentiate this with respect to x. That is a ddx of y upon x, that is x into dy by dx minus y into 1 upon x square. Therefore x into dy by dx minus y is equals to 0. Therefore dy by dx is equals to y upon x. Hence this is the proved. It is again here. Hence it is approved. Now the next is 7th, e raised to x square minus y square upon there is, I think that there is x raised to 7, but whatever that x raised to 7 or x square, like just like as a 7, there is small letter in the textbook. I had taken it as a square. If you see all the examples from the example number 3 to example number 8, the powers of x and y are same. Therefore, we have taken it as a 2. If you take 7, then you can solve that also by using the power 7. That is y square upon x square is equals to 1 minus p upon 1 plus p. Take square root on both sides. And therefore, differentiate this with respect to x. That is the ddx of y upon x. The root of this constant term. In root of 1 minus p upon 1 plus p, that is a 0. Therefore, x into dy by dx minus y is equals to 0. Therefore, dy by dx is equals to y upon x. Now the next is 8th one. Sine of x cube minus y cube upon x cube plus y cube is equals to a cube. In the previous example, the power is I think 7, but I had solved by using the 2. You can solve also 7, the answer is same. Therefore, x cube minus y cube upon x cube plus y cube is equals to sine inverse of a cube is equals to p, cross multiplication. Collect the terms. Y cube upon x cube is equals to 1 minus p upon 1 plus p. Take cube root on both sides. That is cubic root of 1 minus p upon 1 plus p. That is equals to a. Now differentiate this with respect to x. Therefore, x into dy by dx minus y into 1 upon x square. Therefore, dy by dx is equals to y upon x. Therefore, now see this again here. This 2 is a log a, that is equals to p cross multiplication y square upon differentiate with respect to x, and the same the 8th problem. All these are the same types of the problems. Now the question number 5. First example. If log of x plus y is equals to log of xy plus p, where p is a constant, then prove that dy by dx is equals to minus y square upon x square. Now log of x plus y is equals to log of xy plus p. Differentiate this with respect to x. One upon xy into ddx of x plus y, 1 upon xy into ddx of xy, and derivative of p is 0. Now what is the derivative of x is 1, y is dy by dx. On the 1 upon xy, apply the product rule, derivative of x is 1 into y plus x into dy by dx. 1 upon x plus y plus 1 upon x plus y into dy by dx. On the other side, this is the y upon xy, that's y get cancelled, and x upon xy, that is x get cancelled, and you are getting. Therefore, 1 upon x plus y minus 1 upon x is equals to 1 upon y into dy by dx minus 1 upon x plus y into dy by dx. Simplify this. Cross multiplication. Plus x minus x get cancelled, minus y upon x into x plus y minus y into in bracket x plus y into dy by dx, and that's why this minus y upon x is equals to x upon y into dy by dx. Therefore dy by dx is equals to minus y square upon x square. See this again here. Take log, differentiate with respect to x. You can write now also from this dy by dx is equals to minus y square upon x square. Now the next example. If log of x cube minus y cube upon x cube plus y cube to the base 10 is equals to 2, then prove that dy by dx is equals to minus 99x square then show that I had not written the problem, that is the dy by dx is equals to minus 99x square upon 101 y square. This we want to prove. Ten raised to 2, that is 100. Now we have here values. Collect the term of the x and y. Therefore, differentiate this with respect to x. 101 y cube means what? 3y square into dy by dx is equals to 99 into 3 into x square. Therefore dy by dx is equals to minus 99 into 3x square upon 101 into 3y square. 3 get cancelled. Dy by dx is equals to minus 99x square upon 101 into y square. Now the next problem. Hence this is approved. So see this here. That is a 10 raised to 2 means 100. Cross multiplication. 100 and minus 100 and y cube is equals to 99x cube. Differentiate. And you are getting the answer. What is that? Here is a 3x square minus that is upon 3y square. Now next is third one. That is if log of x raised to 4 plus y raised to 4 upon x raised to 4 minus y raised to 4 is equals to 2. Therefore x raised to 4 plus y raised to 4 upon x raised to 4 minus y raised to 4 is equals to 5 raised to 2, that is equals to 25. Therefore x raised to 4 plus y raised to 4 is equals to 25 in bracket x raised to 4 minus y raised to 5. Simplify this, collect the terms. That is x raised to y raised to 4 plus 25y raised to 4. 25x raised to 4 minus x raised to 4. 26 y raised to 4 is equals to 24x raised to 4. Differentiate this with respect to x. Therefore you are getting dy by dx is equals to 24x cube upon 26y cube, and that is nothing but the, I think that is a minus sign. I forget to write it. I think that there is a correction in the answer. This is my answer. If you are agree, then accept it. Otherwise, you solve yourself. Now next is fourth one. If e raised to x plus e raised to y is equals to e raised to x plus y, then show that dy by dx is equals to minus e raised to y minus x. E raised to x plus y, e raised to x plus e raised to y is equals to e raised to x plus y. Now differentiate this with respect to x. The derivative of e raised to x is e raised to x. E raised to y is e raised to y into dy by dx. E raised to x plus y into ddx of x plus y. Therefore, e raised to x plus e raised to y into dy by dx is equals to e raised to x plus y 1 plus in bracket 1 plus dy by dx, and evaluate this. Collect the term of the dy by dx on one side. Therefore, e raised to y into dy by dx minus e raised to x plus y into dy by dx is equals to e raised to x plus y minus e raised to x. Take dy by dx as a common. Is equals to e raised to x plus y minus e raised to x. Dy by dx is equals to e raised to x plus y minus e raised to x upon e raised to y minus e raised to x plus y. That is the dy by dx is equals to e raised to x plus y minus e raised to x, and the value of e raised to x plus y. E raised to x plus y is a e raised to x plus e raised to y, and simplify this, then you will get the answer. That is a minus e raised to x minus e raised to y, these two get cancelled. Next, in the next step, e raised to x keep this numerator as it is. See this again, dy by dx is equals to minus e raised to y minus x. Now see this once again. Last simplification I want to see. What is here? E raised to x plus e raised to y is equals to e raised to x plus y. Okay. Here is it. And here is e raised to, these two terms get cancelled. And e raised to x plus y. E raised to x plus y is nothing but e raised to x plus e raised to y. Okay. E raised to x plus y is nothing but e raised to x plus e raised to y. That is why I am substituting here, and terms get cancelled. These two terms get cancelled. Therefore, minus e raised to y upon e raised to x. Therefore, dy by dx is equals to minus e raised to y minus x, and hence it is approved. See this here again. Differentiate with respect to x. Collect the term of the dy by dx. In one place you are substituting the value of e raised to x plus y. In another place you are substituting the value of e raised to x plus e raised to y. This is important. Next is number 5th. If sine inverse in bracket x raised to 5 minus y raised to 5 upon x raised to 5 plus y raised to 5 is equals to pi by 6, then show that dy by dx is equals to x raised to 4 upon 3y raised to 4. Sine inverse of x raised to 5 minus y raised to 5 upon x raised to 5 plus y raised to 5 is equals to pi by 6. Therefore, x raised to 5 minus y raised to 5 upon x raised to 5 plus y raised to 5 is equals to sine of pi by 6, and sine of pi by 6 is 1 upon 2. Make again cross multiplication. Cross multiplication. Collect the terms of the x on one side, y on another side. 2x raised to 5 minus 2y raised to 5 is equals to x raised to 5 plus y raised to 5. That is a 2x raised to 5 minus x raised to 5. Y raised to 5 plus 2y raised to 5. That is a 3y raised to 5 is equals to x raised to 5. Differentiate this with respect to x. The derivative of x raised to 5 is x raised to 5, that is 5 into x raised to 4 is equals to 3 into 5 into y raised to 4 into dy by dx, and hence dy by dx is equals to x raised to 4 upon 3y raised to 4. And hence it is approved. Now see this again here. Next is, if e raised to y is equals to e raised to x minus y, then show that log of x upon 1 plus log of x bracket square. Sorry, x raised to y. It's not e raised to y. There is a mistake in my writing. That x raised to y is equals to e raised to x minus y. I had corrected it. Take log on both sides. That is y log of x is equals to x minus y log of e. Log of e is 1. Y log x is equals to x minus y. Therefore, y is equals to, that is y plus log y is equals to x. Take y as a common. Then in bracket you will get 1 plus log x is equals to x. Therefore, y is equals to x upon 1 plus log x. Now differentiate this with respect to x. Therefore, dy by dx is equals to 1 plus log x, bracket complete, into derivative of x is 1, minus x into ddx of 1 plus log x upon 1 plus log x bracket square. Therefore, dy by dx is equals to 1 plus log x, derivative of x is 1, minus x, derivative of 1 is 0, log of x is 1 upon x. Therefore, 1 plus log x minus x in bracket 0 plus 1 upon x, that is 1 plus log x, minus x into 1 upon x, that is x get cancelled, you will get minus 1 upon 1 plus log x bracket square. Therefore, log x upon 1 plus log x bracket square. This is dy by dx. It's a bracket square. See this again here. This is not e raised to y. It is a x raised to y. But I had taken here x raised to y is equals to e raised to x minus y. Take log on both sides. That is the log of x raised to y is equals to log of e raised to x minus y. y log x is equals to x minus y log of p, y log x is equals to x minus y log x is equals to x minus y plus y log x is equals to x, that is y in bracket 1 plus log x is equals to x, therefore y is equals to x upon 1 plus log x, differentiate with respect to x, apply the quotient rule, that is 1 plus log x into derivative of x is 1, minus x into ddx of 1 plus log x upon 1 plus log x bracket square, derivative of x is 1, minus x into 1 is 0, log of x is 1 upon x, x get cancel, plus 1 minus 1 get cancel, therefore dy by dx is equals to log of x upon 1 plus log x bracket square. Now next is seventh. If y is equals to in root of cos x plus in root of cos x plus in root of cos x up to the infinity, therefore dy by dx is equals to sin of x upon 1 minus 2y y is equals to cos x plus in root of cos x plus in root of cos x up to the infinity. Now these are the similar problems, squaring on both sides. Therefore y square is equals to cos x plus in root of cos x plus in root of cos x up to the infinity. Therefore y square is equals to cos x plus y differentiate this with respect to x, 2y into dy by dx is equals to minus sin x plus dy by dx. Therefore dy by dx is equals to 2y into dy by dx minus dy by dx is equals to minus sin x, and hence dy by dx is equals to, that is the 2y minus 1 into dy by dx equals to minus sin x, and that is a dy by dx is equals to minus sin x upon 2y minus 1. If you take the minus sin as common, then you will get the sin x upon 1 minus 2y, and hence it is approved. Next is, see this again here, y squaring on both sides, y square, this right hand side get cancelled, you will get y square cos x, and this radicand and next remains as it is, but this is nothing but the y, that y square is equals to cos x plus y, differentiate this with respect to x, y square is 2y, cos is minus sin, y is again dy by dx, collect the terms of the dy by dx on the left hand side, 2y minus 1 into dy by dx is equals to minus sin x, and hence dy by dx is equals to minus sin x upon 2y minus 1, therefore dy by dx is equals to sin x upon 1 minus 2y. Now the next is same type of the problem is also here. If y is equals to in root of log x plus in root of log x plus in root of log x up to the infinity, therefore dy by dx is equals to 1 upon x into 2y minus 1. Now y is equals to in root of log x plus in root of log x plus in root of log x up to the infinity. Squaring on both sides, Therefore, y square is equals to log of x plus in root of log of x plus in root of log of x up to the infinity. That is y square is equals to log x plus y. Now differentiate this with respect to x. Derivative of y square is a 2y into dy by dx. Log of x is 1 upon x and y is a dy by dx. Collect the term of the dy by dx. That is a 2y into dy by dx minus dy by dx is equals to 1 upon x. Take the dy by dx as a common. Then in bracket you will get 2y minus 1 into dy by dx is equals to 1 upon x. Therefore dy by dx is equals to 1 upon x into 2y minus 1, and hence dy by dx is equals to 1 upon x into 2y minus 1. And this is the. Now see this next. See the rest of the log x. Here it is. This remains as it is. Therefore it is 1. Differentiate. Y square is a 2y into dy by dx. Log of x is 1 upon x. Y is a dy by dx. Collect the term of the dy by dx, and it's very easy question. Now next is if y is equals to x raised to x raised to x raised to up to the infinity. The space is not sufficient. Y is equals to x raised to x raised to x raised to x up to the infinity. Then show that dy by dx is equals to y square upon x into 1 minus log of y. Therefore y is equals to x raised to x up to the infinity. Take log on both sides. That is y is equals to x raised to y. Because all the terms are repeated here. Take log on both sides. Log of y is equals to y into log x. Differentiate this with respect to x. Log of y is 1 upon y into dy by dx. Y into log x, product rule. Y as it is, derivative of log of x is 1 upon x, plus log of x, derivative of y is a dy by dx. Collect the term of the dy by dx. Therefore 1 upon y minus log of x, bracket complete, dy by dx is equals to y upon x. Therefore simplify 1 minus y log y upon y into dy by dx is equals to y upon x. Therefore dy by dx is equals to y square upon x into that y square upon 1 minus y into log of x into x. Now the value of log of x is log of y upon y. Log of x is log of y upon y. If we substitute the value, therefore you will get y square upon 1 minus y into log of y upon y, bracket complete into x, and simplify this. You will get y square upon x in bracket 1 minus log y. Henceforth. Also see this here. log of x is equals to log of y upon y. Differentiate with respect to x. Now the next. If e raised to y is equals to y raised to x, then show that dy by dx is equals to log of y bracket square upon log of y minus 1. Now first of all take log on both sides. E raised to y is equals to y raised to x. Y log e is equals to x into log of y. That is y is equals to x log of y. Therefore, now differentiate this with respect to x. Dy by dx is equals to x log of y derivative 1 upon y into dy by dx plus 1 into log of y. Now collect the term of the dy by dx. You will get x upon y into dy by dx. That is dy by dx is equals to x upon y into dy by dx plus log of y. That is dy by dx minus x upon y into dy by dx is equals to log of y. Collect the dy by dx. That is 1 minus x upon y into dy by dx is equals to log y. If you simplify, then you will get y minus x upon y into dy by dx is equals to log y. Therefore, dy by dx is equals to y log of y upon y minus x. Therefore, x into log x into log of y into log of y upon x log of y minus x. That is, we are substituting here the value of y. Y is x log x. That is x into log of y bracket square upon x in bracket log of y minus 1. That is x it cancel log of y bracket square upon log of y minus 1. Therefore, log of y bracket square upon log of y minus 1. Now see this again. This is the important one. If e raised to y is equals to y raised to x, take log on both sides. Y log e is equals to x log of y is equals to x log y. Differentiate dy by dx is equals to x into log of y means 1 upon y into dy by dx plus 1 into log of y. Collect the term of the dy by dx. Dy by dx minus x upon y into dy by dx is equals to log y. 1 minus x upon y into dy by dx is equals to log y. Simplify it. Y minus x upon y into dy by dx is equals to log y. Therefore, dy by dx is equals to y into log of y upon y minus x. Substitute the value of y. That is the value of y is x log y. Therefore, we have x log y, log of y bracket square x. Take x as common, cancel it, and you are getting that is the dy by dx is equals to log of y bracket square upon log of y minus 1, and hence it is a proved. Now in this way we have completed the exercise 1.3. I hope that you would have understood all the problems whatever that I had explained. Now we'll see in the next video. Till then, goodbye.